Okay, so let's look at an example. This is practice quiz 4, number 1. It says use the epsilon delta definition to prove that limit xy goes to 1, 2 of the function 2x plus y plus 3 is 7. Okay, so let's first identify, well, let's actually first look at why this should be the case, then we'll prove it. So if you put 1 in place of x there and 2 in place of y, so it'd be 2 plus 3 would be 7. So intuitively we should know the limit should be 7. Okay, but let's prove it now using the epsilon delta definition. So let's identify our f, our L. Okay. So my f is the 2x plus y plus 3 and the L is 7. So let's draw a picture of what we're trying to show, then we'll show it. So for the limit to exist, then it means that using the epsilon delta, that so delta is just some positive number. So 7 is what we're calling our L here. So if we look at 7 plus epsilon, 7 minus epsilon, this is in the z-axis here. You can think of it sticking up this way if you want, but I'm going to draw it here for easier to see. And the circle's in the xy plane. I have freedom over my radius, but for the epsilon delta is saying I can find a circle such that all the xy values inside the circle map in between here and here. So none of the values map up here or down here. They're all going to lie within 7 plus epsilon, 7 minus epsilon. Okay, so our job is to find the delta that works for any epsilon. So our delta is going to be some sort of function of epsilon. Okay, so let's write our definition of the points in a circle here. So first note, if xy is in the circle here, so this is what we denote by the circle, implies then, well, x minus 1 squared. So the distance pretty much from xy to 1, 2 should be less than delta. That's what this is saying here. Now I'm going to make a substitution. So I'm going to let x equal 1 plus t and y equal 2 plus s. I'll explain how I got that now in a second. Okay, so x is 1 plus t, y is 2 plus s, and pretty much how I got the 1 is from the center. It's a 1 in the x, and 2 is from the y part of the center. Now I'm going to substitute the 1 plus t in place of x over here, and the 2 plus s in place of y right here. So let's do that. So making a substitution then, so putting 1 plus t in place of x, and 2 plus s in place of y here, we'll end up with this 1 plus t minus 1 squared plus 2 plus s minus 2 squared, which reduces just to square root of t squared plus s squared less than delta. Now the t squared is positive and the s squared is positive. The smallest s could be is 0, and so if s was 0, you'd have the square root of t squared, which is just the absolute value of t, and the smallest t could be is 0. So in that case, the biggest s could be is the square root of the absolute value of s could be is less than delta. So let's make an observation here. Okay, so first observation is, well, the absolute value of t is equal to the square root of t squared, and the square root of t squared is going to be less than or equal to the square root of t squared plus s squared, which in turn is less than delta. That means the square root of t, the absolute value of t is less than delta. Okay. In a similar way, we can say the absolute value of s is less than delta also. Let me write it down here. So in similar fashion, we're going to get the absolute value of s is less than delta also. Okay, so our next observation. So now let's look at the absolute value of f minus L. But our f up here is the 2x plus y plus 3, and our L is 7. So making those substitutions down here, we get this. And simplifying this a bit, well, actually we're going to also substitute for x 1 plus t up here, and substitute for y 2 plus s. Let's do that. So making those substitutions, so again in place of x, we're going to put 1 plus t, in place of y, we're going to put 2 plus s. We get this then. Then multiplying that 2 in and simplifying, let's write it over here. So multiplying the 2 in there, we'll have 2 plus 2t plus 2 plus s minus 4. The 2 and this will cross off, so it's be 2t plus s left. I'm going to write it over here. So we have the absolute value of 2t plus s. Okay, and we want this guy to be less than epsilon. Okay, we're going to make an observation now. So I'm out of space here, so I'm going to erase some things. I'm going to erase a few things here and I'll summarize what we have. Okay. Okay, so summarizing, we've shown that the absolute value of t is less than delta, absolute value of s is less than delta, and the absolute value of fxy minus L we showed is equal to absolute value of 2t plus s. We want this guy to be less than epsilon. Okay, so this part here is pretty much, so you put fxy over here. So this is saying that your fxy guy is between 7 plus epsilon and 7 minus epsilon. That's what this is saying here. So we're showing it's equal to absolute value of 2t plus s. Now let's make an observation. So the observation is the absolute value of 2t plus s is less than, or could equal, or equal to 2 times the absolute value of t plus the absolute value of s. So I'll let you think about why this should be the case. For example, if both t and s were positive, then this would equal then in this case. But if t and s had opposite signs, then this side would be strictly less than this side. But this side is always at least as big as this side. Okay, and now we know from up here that the absolute value of t is less than delta, absolute value of s is less than delta. So I can say here, so it's strictly less than, and so in place of absolute value of t, write delta. So in place of absolute value of s, you can write delta also. So that'd be 3 delta then. So 3 delta. So hence we have then, the absolute value of fxy minus L then is less than 3 delta, but it's also less than epsilon. So these two you can equate then. So let's equate those. So equating those, we'll have then 3 delta equals epsilon. I can then solve for delta, so dividing by 3, we'll have delta equals epsilon over 3. So dividing by 3, we have delta equals epsilon over 3, so we're going to say choose delta to equal epsilon over 3. So that'll be our answer then. So pretty much we've shown then, if we choose this radius of this circle to be epsilon over 3, then everything in a circle will map in between 7 plus epsilon and 7 minus epsilon. So everything in a circle will map in this. Okay. Let me just draw that radius in there. Yeah, so if I put my delta to equal epsilon over 3, again, everything in a circle would be mapped into, so 7 plus epsilon, 7 minus epsilon. So if I pick, say, this xy here and mapped it under f, it would go to somewhere in here. So that's then, we prove that the original limit then is equal to 7 using the epsilon delta definition. So again, when you prove using epsilon delta, the last step will always be choose delta to equal some function of epsilon. In this case, it's epsilon over 3. Okay, so we're done. So let's leave it there, this video.